Okay, so all right, welcome guys to today's interview training lecture on graph traversal. Before we start, I kind of want to talk about something special happening on Friday. We have an event, 6 p.m. It's called I Am Remarkable. So what's remarkable about this event? Well, okay, yeah, you? Mhm.
Because it's I am remarkable. So it's
You are remarkable.
yes.
I am remarkable.
Yeah.
We are remarkable. But you know who else is remarkable? Yeah,
My mom.
your mom is remarkable too. But among your mom and all, okay, yes,
Your mom.
my mom too.
Santa Claus?
Santa Claus is remarkable
Yes.
if he was real.
No.
Yeah? Okay, I'm sorry. Huh?
Oh.
Keanu Reeves is very remarkable, man. That guy, mm, yeah.
Bigfoot.
See, Bigfoot's always hiding, so he's not that remarkable. If he was more brave, he would show himself. Yeah.
Groot from Despicable Me.
Gru, you know what? He changed, and I'm glad that he became a better person. But on the real, now that we're done joking around, I want to get to the real. We got 5 Googlers coming to this event. Those are Google employees. One of them is a recruiter for software engineering roles, and the other one is a software engineer himself or herself. I'm not sure what the gender is. But and the rest are I don't know their careers in Google, but this is going to be an event to help you advance in your career, build your brand, be able to talk about yourself to others. And this is an event open to all majors. So it doesn't matter what you study or what career path you want to take. Uh, these 5 Googlers are there to help you out. Start off because starting off is scary and we don't know what we want to do sometimes or how to sell ourselves, and we struggle with that sometimes. So sometimes we just need a good push, and I really think that event is really good for that. Beyond the professional side of this event, we're also gonna have games. So we're gonna actually have build a rapport with these employees. We're gonna play with them, and we're also gonna have some food. So I hope you like Prano's pizza because we order it a lot. But it's pretty good pizza. I personally I think it's better than Pizza Hut, but in my opinion, it's not as good as Domino's or Ray's Pizza. If y'all have ever had that, I love Ray's. I love Ray's Pizza.
The singular. How many Ray's pizzas are there? 'Cause I've only seen the singular Ray's pizza.
Where?
In
Hialeah?
Miami, there's only one. In New York, there's thousands.
Oh, okay, yeah. I mean, the whole
Ray's Pizza in New York?
Yeah. Rays. Looks like a New Yorker.
Reyy.
Oh
No, I saw RAY.
Yeah.
No. Ray's. Okay. So Daniel, I mentioned it before. I'll mention it again. This Friday, 5 Googlers are coming to our event. So it's gonna be one SWE and a SWE recruiter. And doesn't matter what major you are in, they're gonna help you sell yourself. And yeah, just talk about you. And we're also gonna have games and food. So we're gonna.
Do I dress up? Is it like Google?
No,
Style,
just
like-
casual. You can dress up however you want. I think they're dressing up however they want.
Wow.
Of course, the only important part is that you do dress up.
Wait, okay.
Yeah.
Yeah, I don't know. Man. I'm new to this whole recruiting thing, bro.
Mhm.
Yeah, so what is it like? A recruiter's gonna be there? It's like a new.
Yeah, one recruiter that's for SWE roles is gonna be there for software engineering roles. So yeah, food, games. They're gonna play the games with us. It's gonna be great. Yeah, I can't wait to see you there. So okay. So today we're gonna talk about number of islands. So what's the problem? So given an m by x 2D binary grid, where we have a map where the ones represent land and the zeros represent water. So given off this, return the number of islands in the grid. So the way to describe an island is that an island is surrounded by water and it is formed by connecting adjacent lands horizontally or vertically. And you may assume that all four edges of the grid are all surrounded by water. All right, so let's kind of analyze what was said because that was a lot of verbiage. So how many islands are here? Can you count? Why? Yeah, they're all adjacent, right? They're all connected. What about here? Why? They don't connect diagonally. So these like this, they don't connect to be an island. Yo. Yeah. You help them sign in too? Oh, you know his? Okay. Okay. So there's three islands here. This is the one island, another one, another one. This is all the same island. So now your goal is to count the number of islands. So yeah, how do we count the islands that are on the grid? Traverse the array. Well, yeah, we're gonna do that. Okay. And how do we join these ones to be like the same part of the same structure? Right. So let's say we're here. What do we do? Yeah, we can represent that as an index. Yes. Yeah. Yeah. This is 0, 0. Keep track of that. How do we keep track of that? Mm, What do you mean a variable? Well, I mean it's gonna be 1 or 0. So we can start off right like this. I in range when grid j in range when grid 0. And of course we need an answer, right? So what do we say, right? If yeah, then what? Mm-hmm. So we need to when we're here, we need to say that this is connected to this. But we also need to say that this is also connected to this. And this is connected to this. But not only that, we have to also have to say that this is connected to this and this. So what kind of, this is a 2D matrix, but what does this kind of look like when you're connecting components? Doesn't it kind of look like a graph? Yeah? Right? So what if we traverse, so every time you find the one, we traverse it like a graph and just keep going through the ones. Mm-hmm. So what do you think about that? So yeah, so we travel horizontally and vertically and in both directions. No, so diagonally is not part of the same island. It has to be up, down, left, right connection.
So it says that you assume all four edges of the grid are surrounded by water.
Yeah,
So now the entire matrix has only the first example has only one island.
yeah,
Since there is no surrounded by water.
yeah. Well, I mean, this one's surrounded by water. All these ones are connected. They're the same line. Okay. And this one is 3 because this one's by itself. This one's not connected to this one or this one. This one's surrounded by water. All that matters is the up, left, and the down, right. Okay, so let's think about, there are 4 directions, right? And I can represent them in an array. There's directions. I do. I'm getting a little ahead of myself, but this shouldn't be too difficult to understand. Okay, so what is that? What is that? Yeah, so this is, so we know that I is it's this. So that's up, down.
I is rows.
Yeah, I is rows. So that's up, down. So this is down, actually. This is up. This is right. This is left. So those are the directions. So actually, let me, yeah, I gotta comment.
Oh, okay.
Yeah, yeah. Because if you're going down, yeah. I mean, they could have reformatted this any way they wanted, but traditionally, when you go down in rows, right, it's going up the index of the row. That's how it works. So that's down, right, up, left. Okay. So now we need to go over a graph traversal algorithm. Okay. So what are the graph traversal algorithms that we know? Yeah, okay. So the goal today is to do both on this one. We're going to do both. So, okay, I'll be careful not to move too much. So we're actually going to do DFS. Well, we could do one. DFS on INJ. Alright. So we can do this. We can declare inside this function another function, our DFS model. So we're going to do DFS to start off. So help me out here. What should we do? Remember the DFS. Depth for search. So it goes down the depth and goes back up and looks for other ones down other depths, right? Okay, so to start off with, we should have a check, right? So what's our check? We need to check that I and J are proper indices. So what if you're out of bounds? So now you need to account for that. So only if I is between 0 and the length of the grid and huh? We are. We could. I just want to do it in both. That's the point. You want to do it in both.
No, the entire graph could be visited by using DFS, right?
We're gonna do that right now.
But again, revisiting using DFS.
Okay. We're just gonna have 2 ways to solve the problem.
Okay, you're not gonna write DFS and everything one thing, right?
Oh, I think I am. Well, yeah, I am. Okay, I'm going to define BFS. In a real world scenario, you don't do this because that takes up memory when you're defining a function, of course. But we're not in the real world right now, so it's okay. We just want to learn. we can solve this with either DFS or BFS.
And using what you're saying, you can solve that?
Yeah,
Either one.
either.
In the same program, using both.
No, just
Either
one.
one.
We're
That's
one.
what-
We're
that-
going
that-
to
that's
use.
what I'm thinking.
We're only going to use one.
Yeah, that's
So
what I'm thinking.
we can choose. We can choose.
We can choose.
We can choose. Okay. So I and J, I and J are proper indices. So what else do we need to check? When we traverse through the island, what do we need to make sure that we're still in an island?
Like inbound.
Okay, we already did this part. We did the bounce. There's something left to check that we're still in the island.
Oh, the one and zero.
Yes, so that's when you're in water, right? Great.
One is island.
Yeah. Okay, so only if all those test cases pass will this function actually run and do stuff. So this is because recursion, you need a base case, correct? Or else you're going to run this program forever. And, well, not forever. You're going to just fill up the stack to the end. So you don't want to do that. That's what this is for. So what do we do next? We check, we're on a 1. So we're in a valid 1. What do we do?
But it's not visited.
Okay. The neighbors, right? And we define the directions here. So we're going to go from there. So for each there's, and actually I'm going to decompose this to x, y, or I don't know. They are initialized. Okay, so this is the strange thing about the Python interpreter. It can be here, but see, I'm calling it, right, after I defined it, so it's already defined here. So it's okay. The only thing is that it must have already been defined when I'm running it. So it's okay for it to be there. So for each J move, I move, right? Okay. So what do we want to do, right? We want to, for each move, traverse. Going, so I'm an I and J, I want to just move. And that's it. Makes sense, right? Any questions about this?
Where did you get I move and J move?
Okay, so in the DERs, right, each entry is a list of 2 items. So the first item goes to I move, and the second item goes to J move. It's decomposed.
Oh. So then in Python, like when you say like for I move, like you're like defining a variable, like in a for like.
Yeah, I'm decomposing the list. This is a size 2.
We are using Q here. No?
I'm not doing what?
We are not using Q here.
What do you mean Q?
Q is
With the Q?
yeah.
We're not using a Q for DFS. We don't need a Q for DFS. The Q comes later. The Q is the other part. It's the other algorithm. Yeah. 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 So we're going to recursively go through each move. All right. So we're missing a step here. I mean, you'll see what I mean right now. Okay. Yes, we do need to mark them. Oh, let me just run this and show you that this maximum recursion depth. So there's a problem with that. It's a problem, and the problem is actually here. Because see, when we're moving, we're gonna move forward, right? And then we're gonna move back. Yeah, we're gonna keep going. So we need to mark the current one we've been at that has already been seen. Okay, we can just so see we only call DFS when it's one, so we just have to make it not one, right?
Two.
Two or zero. I prefer zero. I mean,
keep an array.
huh?
Or keep an array
But
of visited indexes.
we could do that, but
Memory.
that's extra memory, of course. So we're saving up on memory. So we say grid I j equals zero. So we don't traverse this again. And this time it should work. There. All right. So now let's submit this, and it works. All right.
Can you only do it without DFS?
There is a way to do this the other way, which is BFS. So this goes down to depth, right? Because I'm going down, down, down until I reach the end base case. And I go back up, and I go to its neighboring cases. So the other one is going by level, right? All the levels are put together. That's BFS. Remember that part, which is different. Which I am going to actually define it here. You wouldn't do this in the real world, but here I am. What do you? Oh, you determine that. What is the complexity?
N squared for
N squared? Why
sure.
n squared?
Greater N squared.
Why is it n squared?
Is it N power 4 actually?
It's,
The
it's
worst case?
so the greatest size is m times n.
Yeah, but you're gonna again call DFS n times n in the worst
Yeah.
case.
But we only call DFS when it's
It is
one, but we change it.
0.
So-
Okay.
Mhm.
So, okay, help me here. Tell me.
It's linear, so it's n by n. Yeah, because you only call DFS on that index once.
So there is okay. Assuming you have 4 5 islands, okay,
Mm-hmm.
then still 1, 2, 3, 4 DFS calls within here, right?
Okay. So assuming that we have, I know what you're saying.
Right? Assuming you have
It's
four islands,
it's linear. It is linear. It is linear. Yeah.
even though you have 4 islands, for each island there will be a DFS call, right?
Yeah.
So
Every index that was in that island is already zero, so we don't call DFS on it anymore. The DFS function is only going to either explore a portion of the grid or the whole grid because it's all ones. So in total, the DFS function is just going to do n by n. But then his nested for loops, that's another n by n. So it's n by n plus n by n.
how come it can be plus?
Because the DFS only, in general, at the end, it will only see the whole thing. It's not going to run over the whole grid multiple times for every single time it's called.
It's not plus. Is it plus?
Yeah.
It can be plus only if the DFS is outside of those two columns, not inside of those two columns.
It could be inside because it's only going to explore the grid if there's a 1. And every time it sees a 1, it sets it for 0. Yeah. It's linear. It's kind of complicated to explain. Yeah.
Can you explain how you get the answer?
How do I get the answer?
Yeah, what does the answer actually mean?
So that's how many islands there are.
Yeah, but why does this work?
Yeah,
Okay. So
Derek, can I explain this?
do you want?
Yeah, so that if I say anything wrong, you can correct me.
Yeah, sure.
So, can you scroll to that matrix? Into the matrix? Yeah.
Uh-huh.
So the DFS, what DFS does is, so actually you got the part of IM, right? If any of the edge is 0, okay, the DFS completely makes each of the ones 0. Okay.
Yeah.
Only if at all the edges were 0.
So only if it's 1, you call the function Then you make all the ones that are part of that same island 0. So you don't call that function again. And you only add on to the answer once you find a 1 when you're traversing row-wise in the matrix.
Assuming if you have a 1, 0, 1, 0, 0, 1, 0, 1. You have a 3 by 3 matrix in which A of 0, 0 is 1, A of 0, 2 is 1, and bottom corner, left bottom corner, right bottom corner. Okay, all those were ones. Top corner, top left corner, top right corner,
Right.
bottom left corner, bottom right corner are ones. So in this case, the count will be 4, right? There.
Yes. Yes.
Yeah. So
So, yeah. Pretty good explanation, good example. To keep on track, let's talk about the BFS way of doing it. So the BFS way of doing it is a little differently, right? It takes the same amount of memory, I think. The BFS is the same memory as DFS.
It still goes through the whole island. So yeah.
But I mean, like, it's memory-wise. I mean, I know time-wise is the same.
The only difference is memories is when it's trees.
Yeah.
For the memories, the width for BFS, but for DFS is the height.
Okay. So DFS is height-based memory, and BFS is width.
For trees.
Yeah, for trees. I'm not gonna go too much into what that means, but just trust me on that. So BFS is not the same as DFS. We don't do recursive calls in BFS. There's no. All we use is a DQ or a queue that. Well, yeah, it's basically just a queue where you add to the front and you add to the back and pop from the front, right? So here's what we're gonna do. We want the current J curve, the current coordinates we are at. You want to pop it, pop left, pop in the front from the queue. Okay. Then what we want to do is we're gonna do the same thing here. I'm gonna copy and paste, but I'm not gonna do this. This is collections is a library you import from Python. Yeah, it's a Python library where you can import the DQ class, which is basically an object, a class where it's a queue, right? So you can pop from the left in constant time, whereas popping from a traditional Python list from the front, pop 0, that takes linear time. So this is a faster way of popping from the left.
So you're adding, what are you adding to the queue?
Okay, yeah, so let's get on to that. So we're going to go through our moves, right? And actually, we're going to do new I, new J, and that's going to be the current I plus the I move we're at. And then the new J is going to be the current J plus the J move. Okay. I just do that to kind of like be succinct, be short, because I don't want to have to write this constantly. And we're going to actually use this, this test. So this is important. Why is this important? Yeah, we want to maintain in bounds, and we want to make sure we're adding ones and not anything other than ones, because those are part of the island. And of course, make sure to always change your not notes. Okay. So what's the goal? We want to append to this queue. We want to, first, append the new position, right? Why don't I call this new? Whatever. N means new.
Oh,
Yeah.
It's a queue of INJ.
Yeah. Of I and J positions, exactly. So at first, I'm going to make it 0. Then I'm going to append it. It's a tuple.
So grid is, what is grid?
Well, grid is the same thing. It's just a grid of.
Is grid,
Yeah, it's just the input, the original input.
And then you're setting it to all zeros.
Yeah, I'm setting all the ones that I append to zeros because they're ones, and they're at a valid position. So yeah, this is just me cleaning house. As soon as this becomes empty, so while Q means while Q still has some things in it, keep doing this. But of course, this will run out. This is guaranteed to run out because of this if condition.
Oh, so like
It's
while
not,
Q has like,
yeah.
oh, is that gonna infinitely run?
No, it's not. So it'll stop when it's empty.
Oh, because you're DQ.
Yeah, I'm popping right here because
Oh, I
this
see.
this is not guaranteed to always happen. In fact, the point is that this will stop happening and we just keep popping and it gets empty. And I'm gonna use BFS instead. Run that. There we go. Valid submission. Yeah, it's pretty good memory usage. Although the runtime for DFS is better because when you're popping and appending, that takes time. So that contributed to the runtime of this being slower than DFS. But nonetheless, I kind of like this a little bit more. Just my opinion. This one's shorter, I know, than this. Let me actually just so you guys can compare the two.
Like DFS is so much like cleaner.
Yeah, it is.
You know, it's like
So in DFS, when you add to,
What do you want to know?
oh wait, no, go ahead. Let's see.
You good?
Yeah.
Okay. We good?
kind of.
Hmm.
Oh.
Oh yeah, yeah, yeah.
I was looking at this and no, you're looking at me. Can you do it with a stack?
Can I do it for DFS? Kind of forgot how to do it with a stack. I kind of want to go over the other question.
Okay, yeah, no, that's
Okay.
teach them how to
Okay, you can do this similar to this where you don't need to use recursion.
do it for homework.
Yeah, do that for homework. Do DFS with a stack, which you can go to Geeks for Geeks if you're stuck.
Doing it recursively, does it use a stack?
Sorry?
Doing it recursively, does it use a stack?
Does it use a stack recursively?
Sorry, didn't get the question.
Okay, okay. Does DFS act? Does recursion use stack-like procedures?
Yeah.
Okay, why?
That's how it's done.
Okay, but explain why. Explain why. I'm asking you to explain
Sorry,
why.
why?
Yeah, why? Why does it
You
use?
have to maintain by whom the function is called and what to deliver.
Yeah, in memory, right? Okay, yeah, that's pretty much it. Just to know who's calling what at what certain time in the process. Okay, so this is number of islands, and now we have a similar problem. No, no, not explore. Not explore. Not explore. We got max area. Max area is similar, but it's not quite the same. It is a different goal. All right. All right, here we go. N by N, grid, like always. An island is a group of ones, like before. For directional, we did this. An area is the number of cells with the number 1 in that island. So return the maximum area of an island in the grid. If there is no such island, return 0.
So simply what we did before, except now we keep track of how many, like for example, DFS, when we go down through the island, we now count how many cells we are going through and then compare it for a maximum.
Yes. Okay. So I'm actually gonna pull up number of. Okay, I actually have that. Okay, there we go. Here we go. know that's a real problem. I'm gonna ignore that. So actually, I am going to copy and paste a lot of this, just because
I
it.
have a graph phobia. You're making me feel good.
Well, yeah.
I have a graph phobia.
You have a graph formula?
Phobia. I am scared of graphs.
You're scared of graphs? Uh, it's like swimming. You're scared of the water, and then you can swim later. You know. So I'm gonna use DFS for this. Can you guys see how DFS is useful?
Yeah.
Just going through the ones,
Yeah, yeah, yeah.
but our goal is different.
Yeah. This is actually my first time coding DFS.
Mm-hmm. No.
Yeah,
Yeah.
I see.
Mhm. So now what we want to do is, so let's say we're at an invalid position or it's 0. How many islands are there? 0,
Oh.
right? So return. So outside of the if statement, return 0. But when you're inside the if statement, you want to return something else. So let's say we're at a valid position and we're at a 1. So our answer is at least. So we start off with 1. All right. So now for each move, this is going to provide some answer. This could be 1, this could be 0, this could even be 2. But we want to add it to what? The answer, right. We're adding it to the answer. And then after we go through all the recursively others, yeah, what?
Return the answer.
Yes, we're going to return the answer.
So wouldn't answer be reset? So back to 1.
So answer, it adds up to the DFS. So DFS, we're going through the depth and we'll keep on adding to it. So at the very end, it could be 0. And then we go with 1. But then that 1, so see, it's 1 at first, but it could change. It could become 2. So this one could return 2. Okay, let's go here, right? So at first, the answer for this one is 1. The answer for this one is 1, 1, 1, 0. You know, this is also 0. So this adds on to 0, 0. So the answer for this is 1. But this recursively will return 1, right? So when I come back here, and then this is 1 at first, but then the answer for this was 1. So now this one's 2. Same for this one. 3,
Okay.
then 4.
Okay, I'm thinking like, I don't know. I'm thinking like when you go back to that method,
Mhm.
and then you go back to the if statement. I guess like because you said like answer equals 1 if you wouldn't reset it.
Yeah.
Is that? I guess that's just like.
I do reset it here. I do. So that's actually a good point. So when I'm here, I don't look back, right? I want to add the answer for this to here. So before I go here, this one was made into a 0.
Yeah.
So does that make sense?
Yeah, kind of. So like it just works out like through recursion. But
Yeah.
like you are like incrementing answer.
Yeah, I am incrementing this, and I'm incrementing all of them, right? But except with the exception of this one, right? When I go through all the moves, here, here, and here, and here, this is just 1. But you're seeing this 1, right? But no, I make it a 0 as I'm going through.
Oh, okay, because you're updating.
Yeah, I'm updating.
Oh, okay.
Yeah, so the answer will still be 1. I'll add the answer to this to the answer to this, so that's 2, and so on.
Okay.
Yeah? All right, awesome. So, am I done? I only copied and pasted it. Am I done in this part? Right. Exactly. Ands equals max ands, and this is supposed to be a yeah.
Also, we should take out the
Yeah. Exactly. Yeah. Okay. 0. This equals 1. Let's just see what 1 wrong. It's returning 0. Returning 1 here. It's returning 0.
For this?
Yeah, it is.
Okay, so you're comparing it to a string of 1, supposed to be a number 1.
What?
Line 4 all the way at the end. Instead of string 1, isn't it supposed to be number? This is a list of lists.
Oh, it's a list of one. Okay. I thought this was the same as the last problem. Sorry, guys. I didn't see that part. Read
Line 4.
line 4. 4, 4, 4. Right. I missed that part too. Okay. There we go. Thought it was a string. Reading is important, guys. Reading is very important. Reading is extremely important.
Submit again.
You're gonna mess me up. Oh, a little better. This is just kind of like, I was at 205 here, so. Oh, that one, but that one was a different solution. What do you think the other solution is? Okay, all right. So yeah. Imagine. No, Dijkstra's not useful to this problem. Yeah. Well, Dijkstra. Who knows what Dijkstra is for? No, actually. Well, in a way, he's kind of right. It's kind of search, but not really.
If you're searching for the most optimal path.
Yeah, so it returns you the distance from a single source, the shortest distance to every other path. You can even add the whole path to it, the optimal one. Mm-hmm. Yeah. It is technically right.
So to get the shortest path between 2 points, we use
Between a single source and to all others. Yeah. Yeah.
There's no negative this way.
Yeah. Okay, so Dijkstra doesn't take care of negative cycles, negative weight cycles. It doesn't take care of that. That's something that Bellman Ford will take care of. Oh my God! Copy and paste this, of course, and of course, we're gonna make changes to this.
Are we live with it now?
We are live.
Where's the camera?
The camera is here. I'm using my laptop camera. Yeah, my camera here. All right. So now we're gonna use BFS. So we kind of, it's similar to what we've done before, a little differently. What are we missing here to make it right? Because BFS has to return a number. Let me put this down and just compare the two. See what's missing from BFS that DFS has.
Wait, was that copy? Was that copy and pasted?
Yeah, I copied and pasted.
Same thing.
Yes. So we need to, the way we updated DFS, we need to update BFS.
Zero outside of on the while loop.
Okay. So in DFS, we return 0 because we breached a condition.
Okay, right.
So we need to return. So
That's
okay,
some.
yeah, a sum exactly, and I'm gonna call it answer. Well, let me do this. The answer at first is what? Are you sure?
One, because we know that we have
A 1 in that position, right? We start at 1. And then we want to, at the end of all this, return that. Right? So what do we need to change ands? When and how? When we append, right? Okay, what?
Did you look at the comments on the YouTube video?
Oh, I have not.
For Will, it's on.
Will. Yo, Azar. Will. The direction, yeah. More memory use. Finding the shortest path. I'm sorry, guys. I was getting in the zone here. My bad. Oh, now they're looking at. Now they're looking at my. Actually, let me see something. Okay, you can see it. Okay, you can see my screen. So, well, can you tell me what he's asking? What is he asking?
You want me to put that?
Yeah.
Yeah, I'll keep an eye. I'll let you know who's going to see.
So we need to. So when did we set ands, right? Right before this one, right? So when else do we make it a 0?
After you update, you have to update.
Here, right?
Inside the if statement.
Mm-hmm. That's when we add 1 to the answer. Because we found another 1. Yeah.
Oh, how can answer wouldn't just be like in DFS?
Okay. Here we add up to this. So recursively, we're gonna get the answer. And we just go down the depth till we get to like the end, and then we build up, right? So here it's different. We're just kind of. It's kind of like we're the depth. They're all lined up together. Those are the same depth are lined up together, and we just add the results. And that's it.
Okay.
It's kind of strange, I know, right? It's a little weird how that works, but this is where we change answer in this if statement. So I'm gonna change this D to B. And let me see. Let's compare. Oh, we can compare with these numbers.
Okay, with DFS, more.
Here we go. So less memory, faster.
Oh, BFS.
BFS was faster. It was a better algorithm to solve this problem. Yeah, it probably has something to do with the stack and memory and all that stuff, all that good jazz. I'm not really sure. It worked out better.
Maybe because you get into like dead ends and then have to backtrack with them and tap.
That's a good point because then you get to a dead end. Here you don't get to any dead ends.
With BFS.
Yeah, you don't get to a 0 ever. Do you ever get to a 0 and append it?
Oh.
Exactly.
Oh.
Exactly. Which you kind of do here. So yeah, good catch there. All right. So how do we feel about this BFS and DFS?
Yeah. Recommend Python or Java. Do you ever recommend coding this?
I recommend coding in Python, and the reason I say this is because when you're doing an interview, you need to get it done.
So Python's
Yeah. So you need to write it out. You need to type, and I mean, if you type fast and you're confident in your answer, type in Java. It's just very there's a lot of verbiage, but
What about Kotlin?
you know, as a shout out to Azar, let me see if he's actually saying something weird. Oh, no, he's not saying anything.
Can you actually code this in Python?
Yes, lo-fi is the genre of music. Can I code this in Kotlin?
Yeah.
Can you? Is this even a supported language? Oh, it is.
Yeah, it is.
I'm not going to because I don't know Kotlin that well.
Wait, do that again?
What?
What you did? Go down. Are you doing a racket?
What's a racket?
It's ragged. Well,
How does racket look? Go click on it.
I'll go on it. Ragged. What did I?
Looks like a list with all
The
those phrases.
language-oriented programming language. What?
Wait, what?
What?
Can you go to discussion and search for racket?
I am confident that no way someone did it in Racket, but I'll
Someone
search it
has
up.
to. We have to do the first thing.
Search when racket.
No one. Oh wait, hold on. Hold on.
Yeah.
I need to tag. Nobody did it in Racket.
Yo,
All right, if somebody does it in Racket, you're the first.
this is a new market, yeah.
Yeah, guys, do it in Racket, and you'll be the first one to do it in Racket.
The link is on.
And you're gonna end up saying 100% faster than.
I don't know, bro. I don't.
Yeah, perfect score all around.
Perfect score. If you do it in Racket, we'll let the Googlers know, hey, he did it in Racket, okay? They did it in Racket, because we said so.
I've got 100% in terms of time and memory usage in all of my legacy codes. I code exclusively. in
What are these
Racket.
people saying? Java, Scala, yikes? Scala, yikes? Oh, let me see. Someone did it in Scala. I know that. Three people did it in.
Human friendly. What?
Dude, someone did Union fine for this? Why?
I have no idea, bro. I don't know why.
What is Scala?
It's a programming language in the Java version. Oh my god. Yes, I think it's a JVM. It's made by Oracle or someone there. I have to look that up again, but I'm pretty sure. I could be wrong. I'm gonna check if I'm wrong. If I'm wrong, then I'm fake news, guys. Platform Java. Okay, yeah, JVM. Right. It's on the JVM. Okay, well, like I was saying before, yeah, Daniel, I would recommend Python because you get the data structures, you get all the kinks, the quirks. As far as I know, I think all you need to know are queues, so collections, DQ, min heap, max heap. So that's heap queue, that's heap push, heap pop, heapify on a list. Uh, list comprehension. If you know like these, oh, and dictionaries and hash and sets. If you know all these things pretty well, oh, and tuples. Yeah. Heap queue. So yeah, heap queue, min heap, max heap. Yeah, and that's a priority queue. So that's how you do that. And tuples. So TUPLE.
That's like a dictionary.
No, it's kind of like this part right here where I put the parentheses over two values. That's a tuple.
Yeah, it's a list, but it's immutable.
It's immutable. It's an immutable list. That means you cannot change any part of it. Whereas a list, you can.
Oh, like a final.
Yeah, like a final. So each ij, that's final in that object, that tuple object. So, what else? And then the dictionary, hash set. As long as you know like those, if you practice those things pretty well, you pretty much know everything you need to about Python's language and how to apply it to like data structures and stuff. Also, Geeks for Geeks has some.
Yeah, these pieces. Amazing website.
I think so, Lazaro.
Sometimes their code is pretty dumb.
It sometimes their code doesn't make sense, and
I know Ricky loves it, but no, I hate it.
Which is by Indians. Everyone who code over there are Indians.
well, I like another one by Indians, Tutorials Point.
Yeah, it's good.
I like Tutorials Point. I like that one.
Anyone know there's a website called Interview Bit. Anyone know this? Interview Bit, no?
No. What? How do you spell it?
Interview?
Oh, Interview Bit. Oh, yeah, no, yeah. I was looking up my.
This is actually very good.
I bookmarked it. Yeah, pretty good. JavaScript, React.
Actually, I hate this code. I don't this. You can go to practice. And
Freshers?
see, each bucket.
Freshers?
On the left, it says React interview questions for freshers.
Oh, like people who don't know it that well. For people who are like getting into it. So I'm just like, oh, just more for experience. Then it's experience. Yeah, React. So like the framework. Jetpack. There's a lot of stuff here. Yeah, guys, check out interviewbit.com and you get all these interview questions to prepare.
And also, practice. You can do practice there.
Google interview questions.
Yeah, practice.
Mm-hmm.
Programming. And you can see each bucket where you can, they're segregated properly. Arrays, man, strings, man, search, pointers.
Look, Daniel.
Yeah. So that's why I like this and I hate
Oh,
it.
that's cool.
And if you open one, and you're gonna see topic-wise segregation again. Yeah,
Book free. Wait, what is this? Attend the live? I don't want to attend.
yeah. Just press escape.
Oh, okay, hold on.
That's a cool.
Okay, end tour, end tour, end tour, end tour. So yeah, that's pretty cool. So interview bit, guys. This one looks like it can give you like a lot of like, if you want to get into it, this is pretty good, you know. So you could use this as homework to kind of just get to know these parts, these stuff like a little bit more. Yeah, expand your knowledge and your yeah, pretty much. I think I am going to end it here. I think we did a if yeah, good job.
You
So
select it from graphphobia.
what?
You select it from graphphobia.
Yeah. So BFS, DFS. What's the basic difference we've noticed about the two?
One is recursion, the other one is.
It's not right. That one uses a queue.
Yeah.
Mhm.
Yeah, BFS uses queues. And then DFS uses stacks.
No, opposite.
Oh, BFS uses queues. Yeah,
Yeah.
and DFS does use a stack.
DFS uses
But so you could either use the stack like like an actual stack, like make a stack, or recursion, because recursion itself is a stack operation.
Okay.
You're adding it to memory.
Okay. So stack recursion. So that's like.
It's kind of like a space in memory that you kind of just. Okay, I'm gonna use this. Oh, I'm gonna call it again. Okay, so I'm gonna use another space.
Okay. Interesting.
Yeah, it's pretty interesting
Yeah.
stuff.
Yeah, I have to like practice my Python.
That's
Definitely.
that's actually they teach you that in C, in systems programming, and
They teach Python.
no, they teach that concept of like
Oh,
using
oh.
memory and recursion.
Yeah,
Yeah, and C,
systems.
systems and OS as well.
Simply, I would simply learn Kotlin just to spite Python.
Just despite Python, Python doesn't hurt you. Look at this; it's so short.
So is Python. Python is very clean.
Yeah, I guess that's true.
They made it just like Python. They really did make
Then
it
you
just
may
like
as well just stick to Python, bro. Stick to this, or Kotlin. That too. What does Azar have to say about that? He's not there. Have you already done a lecture on Big O? Yeah, Big O. I did it last semester. I do have the lecture on that in the playlist, the current playlist this is on right now, which is the interview training. Is it on the interview training? Okay,
Every time you go live, you select the interview training.
but I mean from
playlist.
last semester.
Yeah, but you select the interview training playlist every time you go live.
Yeah. I did that right now.
Then everything should be there. Yeah.
Everything is here. This playlist we're on, all that is there. Yeah, if that answers your question, Willie.
David, what's the next week topic? David?
So I'm thinking I'm actually gonna make it Dijkstra.
So, did we do DP? Alright.
Yeah.
We did.
When?
Last week, right?
After we trace, right?
Yeah.
No. We did dynamic programming last week.
Yeah, we did the Fibonacci start, and then we did coin change.
And then I did house robber 1, 2, 3.
No, wait, I did one.
Yeah, you did one.
You
yeah.
did 2 and 3,
Right.
which I wasn't there for because
But tomorrow we go over one part of the problem.
I think I felt. Did I feel sick?
Yeah.
Yeah.
We
And-
do a part of the problem, which
You
is
guys meet weekly?
Yeah, we do this every week.
uh,
At
Mhm.
3:30.
3:30. Yeah, here.
Okay.
Yeah,
So
we're gonna talk
it's
about
cool
single
back to
source
the
shortest path. So
Okay.
Yeah.
Yeah, trying to like, yeah, bro, I'm trying to like study up
Mhm.
my week code.
No, dude, get on that grind and be sure to come out, guys, to the Friday event, 6 p.m. Remember, 5 Googlers, and it's gonna be to your benefit, and you're gonna have some fun. So yeah, I'm ending the stream
Oh, you're
right
still.
now. Yeah, I'm still
They
live.
teach programming? Or is,
They're
gonna
they're gonna.
problem solving? Or
Okay. Friday is gonna be for all majors. Oh yeah, you weren't here. I
This is a
didn't-
seminar. It's kind of saying
Yeah,
what
it's-
Google is about. That's
Yeah,
all.
it's called the I Am Remarkable. It's a seminar by Google. Google's gonna be there. We're gonna host it with them. So yeah, just gonna talk about selling yourself and advancing your career.
So it's kind of a recruitment drive kind of thing.
Kind of. Yeah. Yeah, I would say, yeah, it's a recruitment drive. So thank you everyone for